Hey students, this is Miss Wendt, and I want to get you started on a worksheet called 13E Parallel Circuits. Okay, so it looks like this here, at least the front part there. And at the top it says, a parallel circuit has at least one point where the circuit divides, creating more than one path for current. Each path is called a branch. The current through a branch is called a branch current. If current flows into a branch in a circuit, the same amount of current must flow out again. This rule is known as Kirchhoff's current law. Okay, so in this circuit picture here, you can see we have a 12-volt battery, and the current would leave the battery, go through the path, and then at this point right here, that point, the current's going to branch off into two directions. Okay, and one branch will go all the way around through that bulb, the other branch will just come around here, but at this point they would come back together again. Okay, so the rule is, if we have a certain amount of current, let's say X, that goes into these two branches here, at the end over here we must have the same amount of current leaving. Now, different amounts might go through the branches, but the total going in has to equal the total going out. Okay, so that's what this is all about. All right, second paragraph here. It says, because each branch in a parallel circuit has its own path to the battery, the voltage across each branch is equal to the battery's voltage. If you know the resistance and voltage of a branch, you can calculate the current with Ohm's law. And we used that before. Remember, I stands for current, V is voltage from the battery, and R is the resistance from the light bulbs or the other things using the current. All right, so let's look at problem number 1. And here I've just got it a little bit bigger here to help us out. So use the circuit pictured on the right to answer the questions. What is the voltage across each bulb? All right, well, we have a 12-volt battery, so each bulb is going to get that same 12 volts. Okay, the current in each branch, okay, remember our current, we have a formula. Current is voltage divided by resistance. So if I know my voltage is 12, and if I look at my resistance here, this first branch has a voltage of 2, or I'm sorry, a resistance of 2. So for the first branch, it would be 12 divided by 2, or 6 amps. And then I need to do a separate problem for the other branch. Okay, so however many branches you have, that's how many current you need. But this one happens to have the exact same number, so the other branch will also have 6 amps. Okay, so when it says current for each branch, you need to do the math for each branch. All right, total current, that is going to be the branches added together. So that's total. So that's going to be our 6 amps plus 6 amps, or the total current will be 12. Now in this case, that happens to be the same as the voltage, but that is not always the case. Okay, this total does not have to be the same as the voltage. That's not a thing. All right, then letter D, use the total current. Okay, so we just figured that out, that was 12. And the total voltage, we did that up here, to calculate the total resistance of the circuit. Okay, so total resistance of the circuit. So my formula, current is voltage divided by resistance. All right, so I know my total current was 12 amps. I know my total voltage was 12 volts. I am trying to figure out the resistance. So 12 divided by what equals 12? And the answer for that is going to be 1. So the total resistance of this circuit is 1 ohm. Okay. So that's how you do these types of problems. You have to remember that in parallel circuits, you're going to have more math than the series circuit because you have to treat each branch differently and then kind of add them up together. All right, let's look at another one. Okay, now similar circuit here. Notice that same setup, but our resistance is different. Our light bulbs are different. Okay, so the voltage across each bulb, okay, that's going to be the same as the voltage in the battery. So again, that's going to be 12 volts. Okay, the current in each branch. So we would have to do the math problem to find the current in each branch. Remember our formula, current. Oops, give me your pen. Current. Come on, pen. Is voltage divided by resistance. So for the first branch here, we have a voltage of 12 divided by a resistance of 3. That's going to be 4 amps. Okay, now our second branch, going all the way around, happens to have the same number, so that will also be 4 amps for that branch as well. Now, if these numbers were not the same, we would have to do the math for each one. Total current provided by the battery, then that you will add up the two branches together to get the total. So this inside branch had 4, this outside branch had 4. Total altogether is 8 amps of current. And then to find the total resistance, we're going to take this total current we figured out, the total voltage we figured out, plug it in the formula. So same formula, current is voltage divided by resistance. Now the difference is from doing the letter B is letter B was just using the branch. Down here we're using everything added together. Okay, so our total current added together is 8 amps. Our total voltage was 12, and we do not know the resistance. Okay, but if I take 12 divided by 8 to get my answer, 12 divided by 8 is actually 1.5 ohms of resistance. Now this makes sense. This total I got here is greater than what I got for problem number 1. And that makes sense. These light bulbs have more resistance. So it makes sense that my total resistance was going to be more. Okay. So that's how you do problems where each branch has the same number. Number 3 is a little different because each branch has got a different kind of light bulb and the resistance is different. Okay, so total voltage across the resistor, that's still just the battery. But when I want to find the current for each branch, I need to treat each branch separately. So the first branch, remember current is voltage divided by resistance. My first branch has a resistance of 2. So it would be 12 volts divided by 2. My second branch, the voltage is still 12, but now my resistance is 3. Okay, so this inside first branch is going to have a current of 6 amps, but the outside branch has more resistance there. That one's going to have 4 amps. Okay, so if I was going to compare these light bulbs, this light bulb has less resistance. It's going to burn more brightly. It's going to shine brighter than this guy here. Okay, this first one has 6 amps of current going through. This one only has 4. Okay, total current, add those two branches up, 6 plus 4 gives me a total of 10 amps of current altogether between the two. So that means that right here there is 10 amps going into the branches, and then when these two branches come back out, there's a total of 10 amps coming back out. That's Kirchhoff's law. Whatever goes in have to match. Okay, and then the totals here, remember total current we figured is 10, total voltage up there was 12. I'll let you do the math for that guy. All right. Question 4, very similar, except this time you have 3 branches. So when you do the current for each branch, make sure that you have 3 answers, 1 for each branch. This branch, that branch, and that branch. Okay, so those are places where it branches off, so you're going to need to have a current for each one of those branches. Okay, now there's another formula we can use, because as things start getting a little bigger and more complicated, it gets kind of cumbersome to add everything together. Okay, so when you're finding the total resistance, you're actually kind of using this formula. When there's only 1 or 2 branches, it's easier just to do it by hand. But if you have something really big, you can use this formula here. Okay. What you do is you multiply all the resistors together. So if there's like 10 of them, there would be, 10 numbers all in a row here. And then you would divide it by the total of adding them together. Okay, so this formula here just shows 2. There we go. So you might have 3, 4, maybe all the way up to like 100 if you're talking about like all the resistance in a cell phone or something like that. And then you would add them all up and divide by that. So this is a good formula if you have a whole bunch of resistors kind of all together. Okay, so then you have a couple examples of how to do that. Okay, so if you have 2 8-ohm resistors in parallel, to do the math there, the total resistance would be 8 here. You have the total resistance, it would be 8 multiplied by 8 on the top row, and then underneath would be 8 plus 8. Okay, so 8 times 8 would be 64. 8 plus 8 would be 16. And then you do 64 divided by 16 to get your answer, and I'll let you do the math for that. Okay, so that's just, it's the same kind of thing you were doing before. It's just a different way to do it when your numbers kind of get bigger and bigger and bigger, so it's a shortcut. Okay, now for this problem here, I think it'd be useful to draw a picture of what you're looking at. So it says, find the total resistance of 3 resistors A, B, and C in parallel. Okay, so if you have a circuit with 3 resistors, here's A, here's B, here's C, and then they're in parallel, so then they come back together again, right? So something like that. So this is our picture here, and then each one of these problems gives you different numbers for these guys. So in letter A, you're going to use 8 for all 3 of these. So it'd be 8 times 8 times 8, and then divided by 8 plus 8 plus 8 is how you'd set that up. Okay, for number 2, you're going to have 2 of them that are 6 and 1 that's 2. So the top would be 6 times 2. Just multiply those together. And then you would divide, if my pen would work, 6 plus 2. Okay, and I'll leave the last one for you to figure out. Okay, so this formula would be really useful if you have some kind of electronic device, a cell phone, a computer, where you're trying to figure out the total of everything in there, and maybe you need to figure out what's the best power cord to use or something to that effect. Okay, so a lot of people working in electronics are going to use these formulas a lot. So hopefully this video was helpful for you to kind of get started and work through this worksheet a little bit. As always, if you have any questions, please message me, guys. Have a great day.